Hi everyone, thanks for watching. This is the optional video where I'll go over these three examples that you saw in the regular video just a little bit more slowly in case anyone needs some extra help. Going by the key idea we've been using this whole time, whenever you're answering questions like this, always go with the atomic number first because there's not much to think about and everything else is kind of based off of that. So for neon here with an atomic number of 10, that just means there's 10 protons. You don't have to do anything, there's no work, no math. This selenium atom with an atomic number of 34 has 34 protons, and the same for this one. Always start with those. After that, you can go to the neutrons or electrons next. Doesn't matter, whatever you want to do. I like to do neutrons, just a matter of preference. To get the neutrons, you have to look at the mass. So let's go to a different color here. Use purple. A lot of people get in the habit of using the mass as the neutrons and just filling in 21. But they're forgetting that the mass is not the neutrons, it's the protons and the neutrons added together. So you can make a little equation to help yourself out. Then go back to the fact that the protons are 10. That's a fact, you can't change that. So 10, plug it in, plus the neutrons has to give you 21. Now you're just dealing with a really simple algebra problem. To answer this, you would subtract 10, or to solve this, you'd subtract 10 from both sides. Be left with neutrons equaling 21 minus 10. There's the 11 neutrons we end up with. If you do the same thing here, 80 minus the 34 protons leaves you with, what's 80 minus 34? Leaves you with the 46 neutrons. And same thing here, 82 minus 34 leaves you with 48 neutrons. Lastly, this is the hardest part for a lot of people, are the electrons. Let's go to green for this. To get the electrons, you have to look at the charge, which is found right here in the upper right-hand corner. If your atom doesn't have a charge, like neon, there's nothing written, that means it's neutral. It's not positive, it's not negative. This is the best case scenario, because when you keep score between your positive team protons and negative team electrons, remember the protons are 10, we can't change that. Being neutral means that the score is tied, it's even, they balance, 10 and 10. So there's not really much to think about. For a neutral atom, the electrons will be the same as the protons. Here we've got a little bit more to worry about because there is a charge, it's -2. So when you keep score, positive team versus negative team, remember the positive team, we already know it's 34, you can't change those. So you ask yourself, how many electrons are there going to be so that the negative team is winning by 2? Remember, that's what -2 means. The negative team is winning by 2. And the negative team are the electrons. So just make the score so they're winning by 2. And the way you win by 2 is to have 36 electrons. Same thing here. There's a +4 charge, so keeping score, protons versus electrons. Again, the protons, you can't change those. That's another thing a lot of people try and do, is change 34. That's locked in. We can't change 34. The atomic number is 34. All you can adjust are the electrons so that the positive team this time is winning by 4. That's what +4 means. Positive team wins by 4. That means there has to be 30 electrons. And that's how you do all three.